Let's look at one more example of graphing a quadratic function by hand. This time, instead of finding the vertex with the formula, we'll find the vertex using the completing the square process. So to start, we have a coefficient a of -1/2 in front of the x squared term. It's important in the completing square process that we take that out of the x terms. So we're going to factor -1/2 from the x squared term, so we're just going to be left with x squared. And then we're going to factor it from the x term, -2x. Now, a little reminder, when you take a whole number and you divide it by, or I should say an integer, and divide it by a negative fraction, first of all, watch your signs. A negative divided by a negative is a positive. And secondly, be careful with this division. This is really the whole number times the reciprocal of the fraction. So 1/2, the reciprocal of would be 2. So we actually get 4 when we factor out -1/2 from 2. So we're going to get 4x here. And one thing you can do to double check is distribute that 1/2 through the -1/2 through to see if it makes sense. Now I'm going to leave a space because remember in the completing square process we're going to have a constant term come into for the perfect square binomial, and then we're going to leave the constant term, the 1, outside of the factorization. In the second step we actually complete the square. So we keep the coefficient of a out front, and then we're going to complete the square with the x squared and the 4x. So x squared, when we undo the square, becomes x, and then the trick is to take half of this b value. Half of 4 is 2, and that will create the square for me. To check that, multiply it back out. X plus 2 quantity squared, when you FOIL, will give you x squared plus 4x, and then we get this extra number of 4, which is really this 2 squared. So what I have here is when I complete the square, I get this extra number of 4. Now, that's not really 4 that I'm adding into the equation because it's in the parentheses. So I have to adjust. This 4 gets multiplied by the -1/2. 4 times -1/2 is -2. So what I've really added into the function is a -2. I need to balance that out by adding to the constant I left outside. So now, if you were to multiply that out and collect like terms, it would take you back to where we were originally. But let's keep going with our completing square process. 1 plus 2 would be a +3. And now we have this in vertex form. And from the vertex form, I can see that the vertex is -2, 3. So I have a point at -2, 3. And remember, the graph is going to be symmetric about the vertical line through that vertex, what we call the axis of symmetry. So I'll just put kind of a dashed line there to remind myself that the graph is going to be on either side. And now we can continue with the process of graphing points on one side and mirroring it to the other. Okay. Let's create a table to make this easier to see. So I'm going to create an XY table to create my points on one side. Now, it's going to be easier to go to the right because I will work into 0 and positive numbers. So I would go -1, 0, 1, and potentially 2. Let's see how many points would make sense for this graph. If I start that, and I'm going to show my work up here, I'm going to plug in -1 to start, -1/2 x squared, or -1 squared, minus 2 times -1 plus 1. If I start to multiply this out and collect like terms, what I'm going to notice is that I get a fraction coming up. That fraction is going to be trickier to calculate, and it's also going to make graphing just a little bit trickier. So remember how we can pick any point that works for us, that makes the calculation easier when we're point plotting. So because I know that that -1, this odd number, is going to multiply by the 1/2 and give me a fraction, I'm going to skip that, and I'm going to go ahead and instead start with 0. So I'm going to go back, and instead of using the -1 here, I'm going to use a 0 to start. So I'm going to plug in a 0, and this calculation will be much nicer. So if I plug a 0 in, I'm going to get -1/2 times 0, which is 0, minus 0 plus 1. So I get 1. So I get a value of y for 1. So I have a point at 0, 1, right here. And then again, if I went to and used this next number of 1 in my table, it would give me a fraction. So instead, use the 2. because I don't have a whole lot of room, I'm just going to erase this 0 and put the 2 in and recalculate. So let's do that here. So if I put a 2 in, I get 2 squared is 4 times negative 1/2 would give me a negative 2. Minus 4 plus 1. Negative 2 minus 4 plus 1 would be negative 5. So I get a y value of negative 5 when I put the 2 in. So I'm going to have a point at 2, negative 5. Now, if I go ahead and reflect those across the axis of symmetry, this point at 0, 1 is going to reflect and end up being at negative 4, 1. And this point at 2, negative 5 is going to reflect and end up giving me a point over here at negative 6, negative 5. And remember, one good way to think about that is you should be the same distance on both sides of the axis of symmetry. So we've got a pretty good orientation with this graph. I can connect my points. A little tricky to do on a computer screen. Here we go, and we get a pretty good, nice graph of this quadratic function. As I mentioned before, you can check points. So you could check that point at 0, 1, or you could check the point at 2, negative 5 in the equation and make sure it works. I'll leave that for you.